Volume of revolution using the disk method. Find the volume formed by revolving the region bounded by y equals x squared, y equals 0, and x equals 2 about the x-axis. Step 1. Sketch and visualize. Draw axes and label tick marks. Plot the parabola y equals x squared. Mark the vertical boundary x equals 2. Shade the region between the curve and the x-axis from 0 to 2. When this region spins around the x-axis, it creates a bowl-shaped solid. Step 2. Set up a typical cross-section. At some x value, take a thin slice perpendicular to the x-axis. Its height is y, which equals x squared. When the slice revolves around the x-axis, it forms a solid disk. So the radius r of the disk at position x equals x squared, and the inner radius is 0. The area of that disk is pi times r squared, which becomes pi times x to the fourth. We will use this cross-sectional area in our volume integral. Step 3. Write the volume integral. We add up all of those disk areas from x equals 0 to x equals 2. So the volume equals the integral from 0 to 2 of pi times x to the fourth dx. Step 4. Compute the integral. The antiderivative of x to the fourth is x to the fifth over 5. Evaluate from 0 to 2 to get 32 over 5. Multiply by pi to get the final volume. Thank you for watching. Tap like, share, and comment, and then follow and subscribe for more quick problem-solving tips. Let's make maths simple. One video at a time only on MyVerseNaths.